Good evening, guys. My name is Dr. Lizeka Samba. I'll be your facilitator for this module. I hope I'm going to be as helpful as possible. Let us start with the operations. Today is the 29th. Okay. This is how we do how we think. We are saying, what is an object of learning? You saw the topic. I've set the topic here. The topic is operations. So now you've got your topic. That's what you are going to write when you are journaling, if you want to do some consultation. But when you are studying a topic anyway, you just write a topic and say, what is it that I need to know about this topic? Then what is it that you need to know? You are going to look at it from your notes. It's telling you, Guti, the learning outcome here is to master and apply the basic concepts of mathematical operations. Okay, so the mathematical operation, it is a positive, negative, multiplication, and division. That is what we want to understand, the basic, the language, the discourse around those four. And also you need to recognize, that is another object of learning. You need to recognize and identify the conversions for writing algebraic expressions. Remember, we want to speak algebraically and then also do some calculations. You may think mathematics, you can understand a specific topic, but do you understand those little rules, aboma basics, ama operations, how do they work? Because I saw with your exam, if I'm not mistaken, maybe I'm confusing it with the other module that I'm facilitating. It's multiple choice. It's difficult to work with multiple choice, because with multiple choice, if you have messed up with a sign, you are out of the game. So that's why we need to emphasize on these little things. And the reason why we're doing mathematics is to train our minds, you know. And we also want to apply the laws of the operations in solving the problem. So mathematics is more, it is this special language which we have to speak. There are rules, there are laws, there's a way of doing things here. So that's why you find every time when we are doing a certain topic, there are properties, there are laws. It is one, if ever you can read mathematics from from a spiritual, political perspective, it is one of those courses that were designed to make sure that it eliminates other people from a specific discourse. Because even if you go to high school, people who do maths, they think they've made it. They think they are better than any other person. So that's why you find so many laws that are so restrictive, which makes it so abstract, so difficult. Otherwise, this is so easy. Very, very easy. So now that's what we are going to be doing. That is an object of learning. Then now we say, now on this object of learning, what is it that is critical? You understand? You know what, okay, I need to learn these things. But what is critical? What is critical about this object of learning? So now we are saying, now what is critical about this object of learning the operations, is to know the rules of these. I'm trying to get my pen to write. Okay, so now what is critical about this? There's nothing other than knowing these four creatures. Is it four? We need to know, what are the laws, what is the discourse, how do we think about these things? That's it. There's nothing wonderful about this topic other than understanding the rules. And then there is this law. Tina, like myself, Mina, I know we bought mass, but now there is this new way of naming mass. It is BEMDAS. Okay, so I'll show you BEMDAS. How does it relate to BOTMAS? So if you forget about this BEMDAS, think of BOTMAS, because BOTMAS, that's what we have been sensitized to from back in primary school. So now what is critical? It is critical to know our variables. I will tell you why I have put this thing as critical. I have put variables as critical because you find Guti, there are some of symbols which looks like variables, like this symbol ipi. Ipi looks like it looks like a variable, but it is not a variable because this is a value which is 22/7. So now those are the little misconceptions that you need to be aware of that can be problematic. And then when your lecturers are setting up the exam, they make sure that they put in this so then they can see if ever you are able to identify a variable and a constant. So a symbol pi, it is not a variable, it is a number. Okay, and then we need to know the laws. It's all about the laws and the rules. Okay, so now this is how the mathematicians speak. And now this is what we are used to. Mina, I am so used to bot maths because I did my high school back in the days and my primary school when we were talking about bot maths. So now we know bot maths was brackets of divide, multiplication, add, and subtract. So now there is this one which is BEMDAS, and never mind this one because I took it from. If you go to the internet, this one is PEMDAS. The parenthesis is more like B, so I'm putting B here. So now, what makes a difference between BEMDAS and BOTMAS is because the BEMDAS is highlighting the exponents, and it's also highlighting what. Yeah, it is the exponent, and then the parents is this one, and then you can see that this and that you have got D and M, you've got M and D. There is a misconception of us as learners of mathematics of thinking when you are doing a calculation, you must start by dividing, then a multiplication. It does not really matter whichever one start first. You can see here, Guti, that order has not been taken care of. So you must not worry about that. What is important is you start with your brackets, then the exponents, and then either divide or multiplying, and then addition and subtraction. I will take you through on when you should be aware of when to start using the addition and the subtraction. Okay, here is the here is the BEMDAS according to the notes, to your class notes. I just want to open the PowerPoint on my other side so then I can be able to remember some of the things. So this is coming straight from your notes, and then it's telling you, Guti, for always remember the BEMDAS. You are also going to apply it when you are doing algebraic calculations. So it is important that we think. I'm trying to sensitize to you the way that we think mathematically, and also the language, the discourse, and how do we reason. So now you've got the brackets. You need to perform the operations inside the brackets all the time. That is the rule. If ever you are doing calculations, always start with the brackets. Look for something that has got the brackets. Whether it is in deep at the heart of your expression, start with your brackets. Okay, then you go out, and then you go out. Okay, and then after you sorted out your brackets, you look for anything that looks like an exponent. You resolve that one and make it a number, and a number which does not have an exponent. And then there is multiplication and division. So now if ever you've got these two, it does not matter whichever one you start, whichever one is maybe there's M or there's D, there's multiplication and division, as long as you are starting from left to right. Okay, so it does not really matter. They've got the same priorities. It's because multiplication is a reciprocal of the division. So there's not really there's no really priority between those two. I will take you through on that law. And then there's addition and subtraction. When you've got addition and subtraction, it does not matter as long as you're going to move from left to right. Okay, so now let's come to the order of operations. The repetition again, we are saying The order of operation for complicated calculation is as follows. You perform the operations within the parentheses and then multiply and divide whichever comes first from left. Ne? Whichever one comes first. If ever you've got multiplication and division, as long as you are starting from left to right. Okay, and then follow come with addition and subtraction. It does not matter whichever comes first, but it is important that you cannot start with addition and subtraction ungekenzi multiplication division. That's what we're trying to emphasize here. Let us look at this example. This example, you've got 1 plus 20 multiplied by 6 plus 2 divided by 2. You have got this expression. It's an arithmetic expression. It's got numbers. We don't see any variables, so we call it an arithmetic expression. First thing first, ETE rule. Start with the brackets. Whatever is in the bracket, look inside. Okay. When you go, you said, okay, I'm a bracket Ilana, so I'm going to start here. So here, when I go inside the bracket, it's saying I must add. So I'm going to add whatever I find there. So now it's 6 plus 2. There you are. You've got your 8. Okay. Now you've got this expression. After you've got that expression, you go back to that law of PEMDAS and say, now I've got addition, multiplication, and division. Which one should start? So it is saying start with division and multiplication. You can start from left to right. So the division and multiplication, it is between these. Okay. So now if you're going to start from left to right, so you're going to have 20 times 8. There is 160, and then divide by 2, and then you follow the next step, which is 160 divided by 2, which is 80, and then you get your answer. So this is just the simplest form on how to apply. I would say now it is both maths because you don't have any exponents. Okay, and then let us come here and say now, what are the misconceptions, the common misconceptions that we always come across when we are doing the operations is that the multiplications comes before division. Okay, remember the emphasis is saying these two, you can do them simultaneously as long as you start from left to right, whatever of those numerical examples that you have. Okay, so it does not really, oh, I'm sorry, does not really mean that you must always the multiplication start before division, and then also the addition comes before subtraction. It does not really matter. What matters is you start from left to right. Okay, that is an emphasis. The operations must be performed from left to right. The parentheses must come first. So these are the misconceptions. They are common misconceptions that we always find that makes our lives difficult. So this is how I want you to think when you are writing your journal, is to say, I am doing an object of learning of operations. What is it that I need to know about this? You write them down according to the headings, the learning outcomes, and then you say, what are the critical aspects? What is it that I need to know about these things? I need to know the laws. What laws? BEM does. Okay, what does BEM does do? It is telling me I need to start with brackets, this and this. Those are the critical aspects. And then you come back to yourself and interrogate yourself. What are my difficulties? What is it that I find difficult about this? So now you've got your journal of being your own teacher, helping yourself to understand your difficulties so then you can be able to ask for help. You can't ask for help if ever you don't know what is your problem. Okay, so here's an example. I have picked up my examples from your notes, so then I can speak to the examples. I don't come up with examples that you have never seen before. Yes, I have added some of the examples. Okay, there are some of the examples that I have taken from somewhere, but I have tried to stick by your your notes. Okay, so now here is an example, and I would like to have an interaction with you so then I can see if ever I am talking alone what will be the first step given this expression? Anyone who wants to share? Given this expression, where do you start? Definitely, we're going to apply it BEMTAS, but where do we start? I'm going to open up a platform so then I don't speak alone, because I can speak alone. Mina, I can talk and even forget what there are people. So is anyone who wants to share?
I think we're going to start by multiplying 4 times 3, because we only have multiplication, addition, subtraction, and division. And they
Mm-hmm.
said multiplication and division are the same, but we have to
Yeah.
start from left to right. So because
Yeah.
the first one is 4 times 3, that's where
Mm-hmm.
we are starting.
Mm-hmm. Yeah. And then
And then we're gonna divide. Uh, it's gonna be 4 times 3, which is 12. Divide by 2, which is 6.
mm-hmm. Yeah.
Plus
Mm-hmm.
5 times 6
Mm-hmm.
minus 20.
Do I do anything here?
Um, no, we don't do anything yet because there's a division before the multiplication here.
Okay. Can I ask you a question? If
Yes.
we if we deal with this before coming here, do you think it's going to give us a wrong answer?
Yes, it might. No, if we do with 5 times 6 before we go to.
Before we come here,
Hmm.
it's going to give us a problem. Remember, we are moving from left
To right.
to right, and
Yes.
then we are saying it does not really matter. A division and a multiplication, they are the same.
Yes.
You understand? So if ever you've got multiplication here and then you find that you can just do them, you can do them at the back of your mind at the same time, because they've got the same priority.
Yes. Okay.
You understand? Because
Yes.
now at the same time, remember, we we are not doing arithmetic here. We are trying to skill up ourselves. So now we don't want to be doing step by step at the same time. We don't have time. So
Yes.
now remember, multiplication and division, they've got the same priority. You are not touching anything with the negative. You are only, this is the same, they've got the same priority, this one. So you're moving from left to right.
Yes. Or and then if we're moving from left to right, because after 4 times 3, there is divide by 2. So are we
Yeah.
not gonna have to do with it to divide 2 before we move to the other multiplication, because we're moving from left to right?
This thing could have been done simultaneously. You can do this thing simultaneously
Yes.
and say four times three, which is 4
It's
times
12.
3, it's
12.
12 divided by 2,
Yes, which is 6 now.
which is 6. You
Oh,
understand?
yes.
Yeah. So you do it by inspection. When you are saying you do it by inspection, you don't want to write each and every step, because these have got the same priority. That's what we
Yes.
mean. You understand? They've got the same priority, so you can just do them by inspection if you can handle the numbers, because you can handle 5 times 3, not divided by 2, say 1. You can. So now you don't have to stress. Good, I have to come back next step. Next time we don't have time. There's so much that you need to cover. Understand? So now if you are moving from left to right, you are not doing anything here, and then you do this one, and then you come here. This one, you deal with it, because these have got the same priority.
Priority.
So now you can just do it by inspection. 20 divided by 4, we ask it's 5 times 2,
It's
which is
10.
equal to 10. Yeah, and I understand that by your priority.
Yes.
Then there is no multiplication. Now you get into the space of addition and subtraction. Understand? And then addition and subtraction, ETPM does You start by addition, and then there is subtraction. You are moving from left. It does not matter if ever you've got those two operations. They've got the same priority. What you do is to move from left to right. You understand? So now here, if ever we are moving from left to right, they've got the same priority. No one is the boss of anyone here. It's just that you need to move from left to right. Okay. So now we can do this by inspection, whereby we are going to have 30 plus 6, which is 36, minus 10, that is just going to be equal to 26. Okay. I am taking you through this thinking step by step because some of your assessment can ask you, Uguti, from here, what will be your next, what will be an expression which you are going to apply addition or subtraction. Understand? So it is important to know what, okay, from the first level, I'm going to get the answer where it's going to be an addition and subtraction. So you need to be aware that you are going to be getting this expression. Then from this expression, you can do it by inspection, and then you get the answer. It is just application of the law and the rules. Okay? There's nothing wonderful about the mathematics other than wanting people to think in a special way. So that's why we are saying it is easy in that way. Because if we are yazi, the rule will always apply. Okay? So here is another expression again. What you do, the first thing that you do, you just do the analysis of the question. What is it that is given, is presented with your eyes? You do visual thinking. You are analyzing the symbolic representation. You just analyze, good, oh, I've got 233 minus 9 plus 40 plus 25 minus 30 into brackets. And then you said, okay, fine. I can see I've got so many terms. I don't care who is where. The first target for me, it is the brackets. I'll deal with them later. I need to start worrying about the brackets. So now you are going to say, I've got 233 minus 9 plus 40. I don't care ukuthi kwenzakalani, but I first need to deal with this creature. Okay, this creature is going to be 30 plus 15, which is going to be equal to 45. And then this is going to be 33 minus 9 plus 40. I want to open these brackets. Minus 45. Remember, I am not speaking about distributive property or whatever, because you can do that, but I don't want to go there yet. I just want us to remove the brackets first, and then when you look here, you said, okay, fine, manje, let us start talking. We are talking, this is subtraction and addition. They've got the same priority. I am going to move from left to right. Okay, you can do it by inspection. Those people who've got brain cells that are quick to work, they can help us. Mina, I cannot calculate, I can't deal with numbers. But what is important here, you are going to move from left to right. That's what we are saying here. So now if ever you are and you can even do them at the same time. Okay, so now okay, I've got 33 minus 9, then we have what is going to be 24. It will depend if ever your brain cells can do calculations with so many numbers at once. You can do that. And then you've got plus 40, you've got plus 25 minus 45. Remember, you are moving from left to right. Then base 24 plus 40, this is going to be 64. You will forgive me, guys, if ever I make a mistake with some numbers. I mean, I'm not a number person. I work with variables most of the time. Then you've got 64 plus 25, which is going to be 9, 6, 7, 8 minus 45, which implies that this is going to be 89 minus 45, angiyazi. 89 minus 45. Okay, so now what is this exercise is trying to say to us? We know what is easy to le answer lena, guys, because we've got calculators, but it's not about getting an answer. It's about applying these laws, these rules, and doing them the way that are supposed to be done. Okay, so that's why we are doing these exercises. And I'm sure if you are sitting at home, you've got your daughter or your son is looking at you, guti, Mama uhlulwa into easy kanje. No, it's not about looking at that sum and just get an answer uvele uplake into a calculator. It's all about following the rules, the laws. That's it. Ayikho enye into that we are doing in mathematics. That's what people think people are doing maths are clever. No, there's nothing clever about that. They are the prisoners of laws and rules. That's it. And we come here. Okay? Here, I'd like to get another volunteer to say, if you've got an expression like this, remember the first thing that you do is to analyze. What is it? You analyze that this is a symbolic representation of the numbers. It's got my operations. Remember, my operations go multiplication, go division, go subtraction, those four. So now, what is the law? We go to BEMDAS and ask the God, is God of the operation, and ask him, I must stop calling these people him. It could be a she. And ask this goddess, maybe sounds like a mother, what rules should you apply? So I'm going to ask anyone to suggest to go to, okay, according to OPEMDAS, where where should we start, just following the rules?
We'll start by 3 to the exponent 2 and 2 to the exponent of 2.
Yeah, okay. And that's it.
And then we're going to convert square root of 9 to an exponent
Okay,
so we can solve it.
okay. Square root of 9 is an exponential form, but written it's written in a different way. So without even uhambe uwesesikhathi and converting it, you can just do it by inspection. When we say by inspection, you can just do your calculation, your decisions at the back of your mind without even going to convert it, because square root of 9 is an exponential form, but written ngendlela different. It's a different representation. So that's where we start. There are no brackets according to BEMDAS. So now the following thing is, say, look for any exponents. Deal with the exponents. If you are done with the exponents, go and deal with multiplication and division. So now we are going to start with the exponents. Okay, so now we are going to have 9 multiplied by 7. Square root of 9 is in an exponential form without even showing us. Okay, we know square root of 9 is an exponential form, which is going to be equal to 3 minus 3 multiplied by 8 plus 4 divided by 4. Right? If I'm making a mistake, guys, you must shout, because I may not see. So now ithi manje into ngoba manje so removile ama exponents, the next thing, go and look for multiplication and division. And then when you are looking for multiplication and division, start from left to the right. Okay, so now it means we've got this creature, we've got that creature, we've got these creatures. These creatures, I am combining them because they've got the same priority. I can do them by inspection. Okay, so now 9 multiplied by 7 gives AB is 9 multiplied by 7. That is this is equal to 63. I am leaving this one. Then I've got 8 multiplied by 3 is 24. And then I've got this. And then 4 divided by 4, I'm doing it by inspection. 4 divided by 4 is 1 multiplied by 3. That is going to be equal to 3. You can just do that by inspection. And then now you've got two addition, no subtraction. So what you do, you look from left to right. You've got 63 minus 24, it is 63 minus 24. And then you can do that by inspection without showing us each and every step, because really, as izinto we don't really want to see. So now we are going to get to 42. So here's another application of PEMDAS. We are doing it step by step because we want to stick by the rules and the laws of Ulento, the law of PEMDAS. We follow it the way it's supposed to be done. Not that we cannot do this thing by my calculators A2. We've got powerful calculators that can just help us to get the answer. Okay, here's another example. Okay, I'm not going to go through this example because it's already been calculated for us. This example is saying you first analyze here. Okay, so your analysis, I want a different pen. I want a different pen. So you are starting by here. So now, first thing, what does PEMDAS say? It says, I don't care how complicated your thing is. Go and look for the brackets and deal with your inner brackets. Okay? If you've got multiple brackets, go to the inner heart. Go deeper. It does not matter how many brackets you have. Go to the one which is at the heart of that expression. So the one which is at the heart of that expression will be this one. That's why you've got to 8 land. And then you've got to minus 3. And then you still work from inside, going up, as long as you are still dealing with some brackets. We are about those other guys. They must just wait. You are coming to them. You want to deal with whoever is with the brackets. And then you've got 8 minus 3. You start from inside and then you go out. So 8 minus 3, it is 5. And then after you have that, and then you said, okay, fine, I am done with the brackets. But after the brackets, now that there are no brackets, 5 to the power 2, it is an exponent. So I need to, before I can go and deal no division, no multiplication, no addition, no subtraction, I need to start with some exponents. And then you come here, and then this is that's why from here, because you have analyzed, it's all about doing a visual analysis. Okay, we in mathematics education, we talk about the global approach. Global approach is analyzing your representation. What is it suggesting to me? Okay, this representation, it is saying there is an exponent, and then you simplify that exponent. Okay, and then when you are here, you start asking yourself, okay, fine, here am I, where do I go to from here? I need to target the, now I need to move from division to I need to move from division to either division of multiplication or then addition to subtraction. So now this is where I'm going to come. I am going to start, remember we say you start from left to right. Okay, Mina, I could have done these things simultaneously because no one is going to kill me because they've got the same a priority. So I'm going to do left to right without having this step could have been, I could have had 75 here. I'm not breaking any rule. Okay, so now you've got 8 divided by 4, which is 2. This one, 25 multiplied by 3 is 75. It's just that this one is showing you step by step. Okay, so now once you are here, you've got now addition and subtraction. Remember, it does not matter the addition and the subtraction. You just start from left to right. Okay, if bekuno positive lana bekuno 12 plus 2 bozoqala ngazo, you start from left to right. That is the rule. So now you've got 12 minus 2 left to right plus 75. You could have done that by inspection. That is 85. That is PEMDAS in a nutshell. We are doing this just so we can comply. This is all about compliance. There's nothing wonderful about what we have just done. Okay, here's another one. This one has got ilento, has got square root, and it is lana is so busy. So now remember, we are saying it does not matter in that craziness of that complicated expression, numerical expression. Start with the inner one, the problematic one, which has got so many things inside. Remember here, we are not saying start from left to right. We are saying go to the deeper, okay, with the brackets. Go to the deeper inner bracket. We are not applying all left to right. So now the deeper inner one, which is like a you must think of an example whereby you are going to save. You are wearing ilento, the soldier clothes, and then you've got your gun and whatever. You want to save this person who is trapped. You don't care about those who are trapped in the little trees and little rocks. Ubatla, that one who is trapped deep inside. So this is the one who looks like they are trapped. This one needs to be saved. So now those are the ones that you are going to be dealing with. Okay. So now 3 is just trapped. It's just trapped in a little. Whereas when you're getting to a forest, they're just trapped in a little bush. So you'll come back later. You want the one who is trapped in the deep one. The one who's trapped, who looks like they are trapped in the deeper depth of the forest will be this one. This one, these are just the exponents. 4 to the power 2, which is 16 plus 9. I am doing it by inspection. Okay. If you cannot do those things by inspection, you can write step by step, but this can be done by inspection. You've got 4 to the power 2, which is 16. 16 plus 9, I think is 25. So now this is just 25. So now you have removed that one from the depth of the dungeons of the forest, and then you've got plus, and then you said, okay, let me move to the next one. You are trying to save the people, the numbers here. So you are saying, here is this one, 4 plus 3. He is trapped inside the brackets which are exponents. Let me start by the one who is inside. Okay, so now you've got 4 plus 3, which is 12. So it is 12 to the power 2. So now you say to yourself, all right, what is it that I have here? According to Bemtas Uti, I am still inside. Remember, you're starting from inside and then you're moving out. You said when I'm going inside, Bemtas
Sorry, Doctor.
Uti. Hello?
Yeah, sorry. Is it 4 plus 3 or 4 times 3?
4 plus 3.
Isn't it gonna be 7, not
Yeah,
12?
one. Hey. Yeah, I'm saying 4 times 3. Thanks, ne? That's why I said you must help me. So these are the when I'm talking about ama misconceptions. Uthi uyazicalculatela. Ubona wena engqondweni yakho, your mind is already calculating multiplication. So Tina, as the lecturers, we know those misconceptions. We are going to set multiple choice questions based on your misconceptions that we know, like the one that I've just done. It's not a mistake because I'm looking 4 plus 3. I'm thinking it's 4 multiplied by 3. So now be careful. You have negotiated your relationship with the numbers. You don't just do those common errors. Okay. So you said, okay, fine. Now that I am here, there's still these people that I need to move from AMA brackets. They are still trapped. Who is inside those brackets? It is 3 multiplied by an exponential form of 25, which is a square root, and 7 squared. Let me remove those people, because who BEM does UT, if I want to free these people, I must follow these rules. So now I am still inside, and then I've got this, and then I've got U3. We know U225 is an exponential form, which is 5. And then we know U7 to the power 2 49. Okay. And then while you are here, you say to yourself, okay, I am still inside. Angakaphumi in the forest. Okay. This is my forest. Low square root is my forest. Who is inside? Inside, I've got this and that. So now what is the rule? OPM does uti now. Ngomune multiplication and an addition. Start with the multiplication. So we are going to have 3 multiplied by 5, which is going to be 15 plus 49. And then we said, okay, hey, ngathi soyaphuma at the exit of your forest. One more step, then we've got 49 plus 15. It's 49 plus 15. Ubani loyo 64. Angithi umuva from inside going up. I-square root sika-64 bakwethu siyasazi ukuthi ngu-8. Then kusho ukuthi wena you were using the codes to free this creature u-8. Bongamboni u-8, but the 8 was trapped inside. You had to go inside and use mathematical thinking and use your mathematical reasoning and use the laws to see who is this 8, who is this number that was trapped. So you are using the rules of the operations and also using the law of Ubemdas to free up this poor number 8. That is the thinking, guys. Nothing more, nothing less. If you can train your brain cells to think like that, I promise you, you will never go wrong with your operations. Even if we are going to be doing fractions or whatever, this is how we are going to be doing this. So now I want us to move. This was not a heavy presentation, so I don't think we should stop. So I'm going to proceed, guys. Yeah. So now I am moving, guys, to the variables. Okay, a variable, it is just those alphabets that you'd find. It's an unknown. It is representing an unknown. I'm not going to go into details about it, but we know what are the variables. But what I want to emphasize when we're talking about the variables is be careful. Some of what look like a variable is not a variable. Remember, I've spoken about 2pi. Pi is a variable. U is symbol which is representing a number. 22/7. So if ever you can get a question with exam which is saying pi is a variable, no. You must know it is a value. Okay, you can even press into your calculator, you will get that pi is a number. Okay, so now we are saying now we've got variables, and then we want to build up a discourse here and say, now that we have moved from positive, negative multiplication and division, why should we care about this? We should care about this because we are going to apply it for our algebraic thinking when we are solving equations. That means variables. This is a build up. Everything you are is being given to you as part of your tools that you are going to use in the future as you are moving with each and every topic. So now you are here with variables, and then you said, now how do I speak about those 4 operations? Okay, how do they relate in a context of mathematical expression? Okay, so now if you've got to addition, remember ukuthi like me, my name is Lizeka. My friends call me Malizi. Others, they call me Lizzie. Those are my different names. I know they are calling me. So now you must know, if you get to the word word problems, because as the people who are doing finance, you are not going to be dealing with operations or whatever, abstract kanje. You'll be working with contextualized mathematics. Ilento imaths kuma lento kuma numbers story. There's a story that is being told. So now most of the time you'll find that the story is told with some words. So now if ever you find uthola addition, some of amagama addition you plus and is total altogether. These amagama, amagama that are related to addition. Is subtraction, subtract, we always know, and then take away, we know decrease. Once you see mathematical weights, we're talking about ama weights, ama story, our decrease, you ask about minus, I know good they're talking about an operation of minus, and all of these difference, those are the names that are assigned to a subtraction. And then they say une multiplication you find good is a times, is triple, is a product. Okay, maybe they say a product of a number and a number. We're burning it up. So now you need to know a product is a multiplication. The operation is operation that is taking place here is multiplication. All of these are the synonyms. Okay, so I mean, if you look at mathematics as if it's the people, these are the people surviving, and then when you are coming as this savior, you will see ukuthi mathematics angeke usayizonda. You will see ukuthi uyibhoza coming to save these operations. Okay, because they are telling a story. Okay, you relate to them in a special way. In division, you find that when you find a quotient, we are talking about division. When you're talking about pair, a ratio of something, a percentage, divide into, that is the operation that is taking place there. It is division. Okay, equals is when you've got who is a value of 3 is a value of x is 3, you know what is equal to, that is umele u equal to, you know, those how you interpret ama word problems. Then ama parenthesis is when you've got twice a sum of, that means you've got twice a sum of whatever. A sum, it is an addition. Okay, it's when you have added. Awukhuluma nge-addition, ukhuluma nge-sum of some two numbers or three numbers. So this is just ama words. Remember, when we are talking math, you must know how we name these things. Okay, that is the mathematical discourse. There are names like thina bantu basemhlabeni sinamagama. You understand? There are names of naming these things. So now, once you know those names, you must know, then we are going to see how we use them. Okay? Then I'm saying now, what are the critical aspects? Okay? Remember, what is an object of learning here? I said the object of learning in this phase is to talk about operations within the variables. Okay? So what are the critical aspects? The critical aspects is you must assign a variable, an unknown, to a number ongayazi. Just apply a variable. Mostly x is the most famous number. I don't know why. A most famous variable. You can use others, but nami I like x because I'm so familiar to it. And then you've got or words or sum or total or difference or product. As I have on the previous slide, I have sensitized you to that common language. And then ama parentheses, that will be ama brackets. And then here's an example ukuthi a phrase, the sum of 3 times a number and 5, translate to a sum of 3 times a number. This is 3 times a number. When we are saying a sum, you are going to add nango 5 unikezwe. So here you are translating a word problem into an algebraic expression. Okay, so now this is I will take you through now on how you combine AMA variables with AMA operations in a space of AMA word problems. Okay, that's where they are taking place. That's how they speak to each other. They speak to each other in a space of AMA word problems. Okay, that is not the only space where they converse with each other. They converse in other spaces, but right now I want us to see how they speak when the mathematics is embedded in a context. Okay, so here is the it's just something that I have pulled out somewhere. I'm going to have a copy of this presentation, so then you can have these for your reference. If you want to go back and understand these words, what do we mean by them? Okay, this is just a repetition. when you've got plus, this is an example, a number plus 3. We don't know this number, so we are going to assign it a value of x. So now that's how it translates. So now we are moving from a word problem into an algebraic expression. Okay, more than i-addition imnandi, yes, because everything is just you are adding. Akuna stress, so minus or whatever. More than 10, more than a number is always you are adding. A sum is always relating to addition. So a sum of a number and 5, here is an algebraic expression of that. A total of 6 and some number, that means you've got 6 and some number ongayazi, that number x ongasolveki. There are people who even sang about it. So x is very famous variable in mathematics. A number increased by 2, that means you've got x plus 2. You need to be very careful manje kumanye amalento ama-expressions ne amanye ama-word problems ukuthi check what is your misconceptions, because abanye abantu bangavele bathi a number increased by 2. We understand? So now make sure to understand this language, because there is a there could be a misconception whereby ungacabanga ukuthi, because you are saying a number is increased, any number is going to be increased, but here it is doubled, it's not increased. When we are saying increased by, that's why these keywords, you must keep them in mind, so then they can help you with your misconceptions. Because when they say a number is increased by 2, I can easily think it's 2 multiplied by that number, but no, it does not mean that. It is saying a number is increased. When you are saying is increased, the key here, it is this: increased by means you add. We understand? So make sure Guti, you are able to resolve that misconception. It is easy to think it's 2 multiplied by that number. Okay, added 2 is easy. You just take a number, you add it. That one is straightforward. Let's look at the misconceptions that you can come across when there's subtraction. Minus, a number minus 7. That is straightforward. A number minus 7. 4 less than a number. So this one, it is simple. It is 4 less than a number. So now here you can have the misconception here. If we fund straight the way a corner, we understand uti 4 less than a number in general, the way you fund a corner. But you need to be careful uti what is the meaning of that. The meaning of less than 4 less than, it is saying you've got x less than that number. Okay, so now be careful of this, because you can easily, if you are going to read, we call it misconception. A misconception is when you apply something, you've applied it before, it was correct, but it is incorrect in a specific context. So be careful. Try and see exercises ukuthi ungayenzi a mistake. When you've got less than 4 less than a number, it means you've got a number minus 4. Okay, and then you've got a difference. A difference is straightforward. It is a difference of a number and 3. That one is straightforward. You don't have to. I have not seen any misconceptions with that one. 9 less than a number. This one, 9 less a number. We have only silung. Isilung sometimes is shy. That's why we must have mathematics in maybe in our languages, because you've got this one. You've got this one. This one is saying less than. This one is saying less. Okay. When you've got less, you can just read it as it is. You've got 9 less a number. Okay. But if you're going to say 9 less than, 9 less than a number, you would mean you are going to have x minus 9. Okay, be careful of the keywords, the key phrases that would find that have got a mathematical definition. Okay, decreased by, a number decreased by 12. Okay, a number decreased by 12 is straightforward. I don't see any misconceptions that may emanate from that. 6 subtracted from a number. If you are going to read this thing as the way in a corner uzoba senkingen, 6 subtracted from a number, it does not work further. It is 6, subtract 6 from a number. Understand? So now this is the number, then you subtract to 6. That's what it means. Just say this thing in your own everyday language, in your Zulu or Xhosa or Sotho. U6 umsusa from a number. Okay, not the way it is written and say 6 separated from a number. So these are the misconceptions. Be careful about these ones. You can easily confuse them. So I've put this one as as more of a dictionary. Okay, you can put this thing as your dictionary to help you remember when you're writing your assignment, when you are answering questions that have got something to do with AMA keywords. Start practicing and see the language. This is a language. This is how the mathematicians speak. Okay, now in multiplication yona it's rather straightforward. In multiplication into ethanda ukuba problematic i-subtraction inenkinga kakhulu. And I can see, you know what, I can see now from an esoteric information ukuthi a negative number is always associated with negative feelings. So anything, if you are doing calculations that have got something to do with subtraction, the misconceptions always come out. So there is something about the negative number. That's why I am saying maths is one of those subjects that were designed to put an order, to make people behave in a certain way. You know, there's something about maths because anything to do with with imat anything to do with subtraction, not division. Even if division is problematic in the political context, you are dividing and ruling. It's a negative feeling. Those two are problematic. So keep in mind, look any misconception. So I am trying to drive your mind to see where are the possible misconceptions when you are doing calculations. You'll find possible misconceptions with the two operations in multiplication and subtraction. Check if ever you are fine, you don't have any difficulties, you can maneuver. If you can maneuver there, then you are the boss. You don't have to worry any further. Multiplication is straightforward. You've got 8 times the number here, and then product of 14 and a number. It is just straightforward. You just need to understand the language. Twice a number, double a number is straightforward. A number multiplied by a negative 6, that is straightforward. 3/4 of a number, 3/4 of a number. When you've got 4, these are your keywords. Okay, these are your keywords. In division, you've got a word called quotient. A quotient of a number and 7. So this is how you would write it. 10 divided by a number. This will be your algebraic expression. A ratio of a number to 10th to 15th. So now that will be x. That is a number divided by 15. This can sometimes be named as a ratio of a number to 15. That is a division. Okay, there are problems with division and subtraction, so make sure you resolve any misconceptions and difficulties with those two operations. Powers, a square of squared, a number, a square of a number squared, that will be the algebraic expression. A cube of a number is just a cube of a number, which is just x to the power 3. And then who equals to who equals to by way to who equals to something is equal to something. Okay, here are the keywords. Look for these keywords when you are analyzing what you call your word problems. So I am going to give you this as your Bible, that you can always go and refer to this common language. Okay, and now let us see how we apply these things in the Guma calculations, Guma word problems. Now remember, the first thing that you do as the mathematicians, as a disciplined comrade of mathematics, is to analyze what is it that you are given. Read it. That is a global approach. Lento iti, the difference, the minute one out difference, we ask good way, I need to apply a subtraction. A difference of two numbers is 10. Statementless. And the sum of their squares is 50. So now you've got two numbers. So now we are saying let those numbers be x. Let those numbers be x and y. Okay, because we actually about two numbers, but a difference between those two. Awuyazi ukuthi yeyiphi ezoba phambili yeyiphi ezoba emva kodwa uyazi ukuthi a difference between those two. So now the first statement, it is saying a difference between these two is, remember, go back, if ever ubuyela back lento kwiBhayibhile yethu sithe if ever uno is, u-is umele bani, umele u-equal to, sithe u-difference kuzobe u-operator nge-operation u-minus. Okay, so now I am applying all that Bible, those rules, those keywords into an algebraic, into a word problem. Sum of their squares. This is another statement. Sum of their squares. Remember, what are those numbers? No x, no y. Is sum sithe ngu plus. Square is when you are going to square them. So now a sum of them, you're going to have x squared. We are summing them is equal to 50. I am not going to go through ukusolve abantwana basekhaya. If ever you are interested in doing simultaneous equations, I will definitely help you if ever you are struggling. But if you want to solve those two numbers, my aim today, guys, that is the object of learning, is to help you to think about operations, variables, word problems. How do you analyze them and decontextualize your word problems using the rules of Bodmas? That's the only thing that I'm doing today, not to solve. Ne? So now, if you want to solve this one, this is going to be your equation 1. This is going to be your equation 2. You can solve this simultaneously. We are not going to do that. If ever you've gone to a section whereby you are required to do simultaneous equations and then you are struggling, please give me a shout. Okay, I just want to help you to decontextualize these things. Here is another one. We're saying now 5 years ago, just ukhuluma nje isintu in your own language. 5 years ago, into edlulile is in the past, is in the negative, it is subtracting. Ago, you are past that. So you already know when you've got 5 years ago, is something that has passed, it is minus. Okay, you are thinking of an operation of negative. John, age got John was half the age he will be in 8 years. Okay, so now John's age, the variable here is age got John. Okay, John age yakhe was half then. Okay, so now for you to decontextualize that and put it in the algebraic expression, iti manje John una x, because you don't know age yakhe manje, but we are going to say he is x. Okay, so now we say 5 years ago. From now minus 5 years. Ne, age yakhe is, okay, was or is, was. So this is going to be equal to lo was lo. 5 years ago. So now you've got 5 years, you've got age. Ago, it is his age minus 5 years. Okay? Was lo, lo. Umele u equal to. Remember, who is, no was in English. Those are two things, one in the present and one in the past. This word problem is a past. So now who is, no was. Also was is equal to, and then bati half age he will be. Remember, into ozoba yiyo. You are adding, you are looking in the future. So it's going to be will be half of whatever he will be. So now hence you are going to have half of what he will be. He will be in 8 years. Age he will be. That's why you've got age plus x. Age, that is your age he will be, is x plus f. But this is the half of it. So hence you come to this expression. Okay, you move from here to this expression. This is 5 years ago. Okay, 5 years ago, that is, you are saying x minus 5 years, he was, that is equal to half of what he will be. That means what he will be, his age is x plus. So hence you've got this mathematical expression. I'm not going to solve it. It is just to help you to think. How do you think about the word problems using the keywords that I have discussed. Okay. What are the common misconceptions? I just want to throw to you so then you can see if ever you relate or not to those to those misconceptions. There are many. Oh, now I'm looking at the time and I'm trying to cover as much as possible. Okay, and I'm moving because I want to highlight all of the objects of learning about the about operations. Any problem that you'd find this notion of a substitution. Okay, a substitution is when you have to substitute. It's when maybe 2x plus 1, but let x to be equal to 2. So now you need to substitute this thing here. Kuba nama-problems amaningi. Uthole ukuthi umuntu manje awuzitholi izinto right ngoba you have performed izinto ngendlela why nginamapeni ayi-2 ayabhora lama-colors. I need something bright. Okay, so now good am problems of substitution. A meaning of AB. Let's say AB means you multiply A plus B, and then if ever you've got A is equal to 3, no B is equal to 5, AB is equal to 3 multiplied by 5 and not 35. Be careful about this. Look for all those common errors that you might have. Okay, ungacabanga ukuthi these things are very easy. Sometimes, like me, you saw with me, I said 4 plus 3 is equal to 12. I mean, you understand? So watch out for those things when you're doing a substitution. UBEMDAS, famous bantwana basekhaya. You can't just ignore UBEMDAS because UBEMDAS uthi ngicela ungi-apply every time you are working with the 4 operations. Ama-4 operations are problematic awafaka at the one expression. So how do you work with the operations? You need to think, oh, if I've got an expression with so many operations like I4, you can't just do any other thing other than apply like UBEMDAS. Okay, so now you need to follow that rule because it's going to help you to unlock anything that has been is being captured by the operations. Okay, other mistakes that you find when you're doing substitution, most of the time, abantu kunzima when you're working with negative numbers are problematic. Honestly, they are problematic if ever you've got negative let's say you've got negative 2x plus 1, and then you say let x is equal to negative 3. Okay, you are going to have negative 2 into you kumele usubstitute u-negative the way angakhona. Okay, u-negative utshintsha iy'mpilo zabantu, so be careful ukuthi you have made peace. It's like if you're going to use an esoteric knowledge, it's a demonic number because it's always giving problems. You need to always be careful when you're working with it. Okay, so now you can easily say it is 3 uvela 3 and then so itholinte wrong already. Yeah, man. And then you've the most common mistake is thinking that a negative number squared give a negative answer. If ever you've got negative 3, if this thing is squared, you are going to get negative 9. That's not the case. Okay. Another thing with a square is when you've got negative 2 cubed and think this is going to be equal to 8. Now, cube, this is going to be negative. Okay, we are not there, but negative number uyinkinga we mathematics. I am highlighting these to you so then you can be sensitive to negative number because it's a kind of a demonic number in a way. Okay, let us try UBEMDAS here. Okay, I'll start with the first one. The first one, this is what you are given. We are going to substitute. So now if ever I'm moving from here, I'm going to have U2 into my A is 2 plus B wami ngu 1, C wami ngu 7, is minus 7, and then, you right? Yes, plus 7 into my B is 1 minus 2. Okay, so now remember, I've got this creature, I've got my brackets, I've got an expression. BEMDAS is saying, look within your brackets first, starting from left to right. So now I'm going to go inside. Remember, when I'm inside, I can see good, I've got addition and subtraction. It does not matter. They have the same priority, but I'm going to start from left to right. I'm going to do this thing by inspection. 2 plus 1 is 3. 3 minus 7, that is going to be equal to minus 4, right? I think so. 4, 5, 6, 7. It's minus 4 plus 7. 1 minus 2, that is going to be minus 1. You need to be careful about AMA signs. When there is a negative number involved, things start going ngenye indlela nje. So now you still have inkinga yama brackets. Okay, you need to deal with AMA brackets. So 2 multiplied by negative 4, that is going to be negative 8. And then I'm going to have positive multiplied by negative. This is going to be negative 7. And then this is going to be negative 15. Okay, so now I've applied to BEMDAS through focusing on a substitution. Let us look at UB. Okay, I am going to just, I'm not going to rewrite this. I'm just going to substitute from here. Okay, substituting from here, I've got a squared, which is 2 squared plus 1 squared plus 7 squared. I can do, this is 2 squared, which is 4 plus 1 plus 49, which is going to be equal to 49 plus 1, which is 50. 50 plus 4, that is going to be your 54. That was a simple substitution. And then I'm going to come here on UC. UC, I'm going to have UA, which is 2 plus 1 into 1 minus C. All right, so this is going to be equal to, I've got brackets and brackets. I'm applying BEMDAS or BODMAS. I've got brackets and brackets. 2 plus 1, it is 3. 1 minus C is 1 minus C. Hello?
It's going to be 1 minus 7, so which is negative 6.
Oh, uyabona ukuthi sengilele mina, ngilele. 1 minus 7 ubani kwasho? Minus 6, ne? Then I've got my brackets. 3 multiplied by minus 3, ubani loyo minus 18, ne? Okay, this one was just straightforward. I guess sizameni lena bazalwane. Let's bring this thing here, ne? Awuthi ngizokwazi ukucaceleka kahle. I need a different pen. I need a different color. All right, to read. Okay, la ngizala. Okay, so then this is number D. Careful when you are doing substitution to be 2 into ubi wakho ngu-1 minus ubani, you right? Uc wakho is 7 plus 3 over u-a wethu ngu-2 UB ngu-1 squared. I hope bahlali you can follow my mistakes. Those those things of sleeping when you are doing gamma calculations can become a pattern. Make sure that when it's a mistake, let it be a genuine mistake. Ingabi into ebuilder as a misconception. Ne? So you've got U2 minus, ne? So I'm moving from left to right here. I mean, this one, U2 multiplied by 1, I can do it by inspection. 7 plus 3 is 10, 10 over 2. I'm just doing that, solving that expression, yes, courtesy 1. Okay, this one. This is going to be 10 over
Doctor, but
2.
there is an exponent, so don't we start with an exponent before we multiply? It's b squared,
which is equal to, yes, um you start by it, but I'm glad that you are asking that question, Mingoba. If ever uzovele wenza izinto the way I've done them, because I see it's a simplified expression, you will apply it in the cases whereby izokunikeza ama-mistakes. So thank you for raising that. It's important to see apply ubedmas, even if, especially at your level. You understand? Especially at your level, because that is where you are going to be assessed. U-assesswa ukuthi uyakwazi na ku-apply leyo rule. Thank you so much for highlighting that. Mina sengicabanga ngezi sengijahile. So thank you, because that's where you will be assessed. So now it means from this step, ne, we are going to say we are going to have one way two. So here we are going to have 7 plus 3 over 2, ne? This implies that you are going to have, and then you said, okay, fine, I've got 2. This thing has got a division. You've got a numerator and a denominator. That is a division. Now come to a division. You're going to have 2 minus. So let us work with this one, because it is a numerator and a denominator. Let's simplify that. On your numerator, you're going to have 10. On your denominator, you're going to have 2 plus 1. This is still a division problem. So now we are going to have 2 minus 5 plus 1. Now you've got a simplified thing. So now it's not simplified. You have to use the addition and subtraction. So you're going to have, starting from left to right, you're going to have 2 minus 5. 2 minus 5 is going to be -3. You need to apply the rules of addition and subtraction. When the signs are not the same, you subtract and take the sign of a bigger number. I am applying the rules of addition and subtraction. So 1 minus 5, 2 minus 5, the signs are not the same. So I'm going to subtract and take the sign of a bigger number. 2 minus 5 is -3 plus 1. So now here I'm going to have -3 plus 1, which is going to be equal to -2. Okay, so guys, you can see ule number lo, negative number uneyinkinga eziningi. Okay, so now that is, uyabona i-substitution. I-substitution led us to bring in ama-rules e-addition ne-subtraction. I hope I am going to have time, as we will be doing these sessions, to take you through on how you do, oh, positive multiplied by positive is positive, all those, because now you need to bring them in. We did not talk about those. Okay, but when you come to a substitution, you need to bring in that language, so then you can be able to get your substitution correct, because there are some other laws and rules that you need to apply. Without wasting time, guys, I'll quickly go through ama-laws, ama-operations. Ama-laws of ama-operations, kune-commutative. I-commutative i-aplya ku-addition nakwi-multiplication. Okay, as long as you know ukuthi division ne-subtraction, ziyabheda lezi zinto eziyi-2, they are problematic. So that's why you find even nakwi-commutative law they do not apply. You've got the associative law, similar. I-division i-division ne-subtraction, they don't apply those. This associative law. Then you've got a distributive law. Okay, and then here is what I'm saying. A communicative worked when you have swapped the numbers. If you've got 5 plus 2, those two numbers, you can always, because they are the same, they've got the same sign, you can swap them around to 2 instead. That is a commutative law. You can also even apply it no matter when in multiplication. If ever 5 multiplied by 2, this can be written as 2 multiplied by 5. In algebraic terms, ungaba no xy. This is the same as yx. Sometimes I'll solve ama-algebraic expressions. Uyafuna ama-expressions uwajike afane. You can only do so if ever unento enje nento enje, or that and that. Okay, so kodwa leyo nto leyo, you need to be careful. I-multiplication, ilento you cannot apply that with division nakwi-subtractions. Those are demonic operations. Then associative, I-associative ithi you can start anywhere. Ungaqala u-ede u-3 no-6 bese u-add u-5 later, you'll still get the same answer. Or unga-eda u-5 no-3 awuqeda ugcine ngo-6, and then lastly you know you can shop around and start with anyone. When you've got positive number, there is harmony, there is peace, things are in a meditative mode, everything is calm. Bring in when it's subtraction, there are going to be problems. So that's what we mean with associative property. You can start anywhere. So now even with multiplication, you can have 3 multiplied by 4 multiplied by 2. You can start by 4 multiplied by 2 and then finish off with 3, or you can start multiplying 3 and 2 and then later with 4. You will still get the same answer. Problems start with multiplication, division. You can't do that. So if division and subtraction are restrictive, that they've got a problem with mathematics. So we need to always be careful about them. Then basis banet distributive property. A distributive property I'll take you through is when you've got an expression, a variable density distributor omnyumtana who is outside to anybody that is inside. That is distributive property. Lona distributor lana, then uba no x squared. Lona distributor lapana, then uba no x. That is what we mean about distributive property. Remember, the aim of this module, guys, is for you to understand the laws. Ne? Is for you to understand the laws. Now, communicative property of addition. Here's one example which is similar to what I've given you. In multiplication, here's an example. This is just a repetition, Bashali. There's nothing new there. And then here is another example of a commutative. I've put it, here is the words. Changing in order of identities does not change the sum. This is just it's like a theorem. And then this is an algebraic form. These are the numbers, example of the numbers. Here is an example of mental calculation. You can go through these slides, because this I am I'm a visual literate person. Mina ngiyakuthanda iy'thombe, ngiyazithanda kakhulu. I study with the numbers. I'm even working with grade 7 because I hate ngibathanda abantwana grade 12 because they are always thinking they've made it. They want to work nama abstract numbers. So I like to use pictures so then these things can stay in my mind. So now this is just a picture which makes you remember and makes you fall in love with maths even though it is horrible. So this is also a commutative property. I've discussed it. I'm just showing you how does it look like in an algebraic form. How does it look like? Are you numbers? An example when you're doing mental math. Mental math is when you're doing calculation at the back of your mind without using even a calculator. Okay, it is just a representation, a different representation, so then it can make you remember and makes this horrible maths fun. Okay, the associative property is when we say you can start anywhere. Ungaqala u-ede laba, or ungaqala u-ede labana boyithu, you'll still get the same thing. That's what we mean with associative property. I've got a representation of it using this beautiful picture. I've got an algebraic form of an example. Numbers, even in mental calculation, this is indeed true. Okay, and then what is this? This is a repetition what I've already have there. My apologies. Oh, I see repetition. It is of multiplication. This is an example of multiplication. These are the numbers. This is an example. Kwenzakalani lana? It is repetitive property. It is repetitive property. Whoever is outside, umfake umncede, umfake ngaphakathi. So if you've got an expression like this, distribute this one here. This is what this. Distribute this one there. This is that. Okay. Then when you are here, how do you solve? From here, we apply this horrible PEMDAS. Can you see how these things are pulling each other together? If you were to solve here, you would apply ulento PEMDAS. Okay. Here, distribute this one here. This will be an expression. distributor this one here, this will be an expression. Ugu solver will apply this law to solve. Okay, we are trying to understand this way of thinking. Here, then I mean, I've just done an algebraic way of talking about this, an example with the numbers, and also a mental maths. Okay, so then it becomes more like of a Bible that you can always go and refer to. Here, I am just throwing identity properties. A multiplied by zero is always a, any if you multiply by zero or total zero, we know that if you multiply a number by one, you'll always get that number. If you add a number, an additive inverse of a number, you will always get to zero. That means if ever two, the additive inverse got 2 is minus 2, total 0. Understand? The additive inverse got negative 4 is positive 4. We will always total 0. That's what this means. Okay. So now the product of any number and its inverse is always going to be equal to 1. If ever 2, the inverse got 2 is 1 over 2. It's like you're flipping the thing is going to be equal to 1. If ever 3 over 4, multiplicative inverse of this, it is 4 over 3. We will go to 1. Does not matter what. Okay, so now these are some of the properties. This is just a summary. It's a summary of everything about AMA laws of AMA operations. I liked this color because it's blue. I love blue because it looks so attractive. So I just put this thing as a summary. There's nothing new. It is just a repetition of the summaries that I've put already. So now here you are just asked to, what I'm going to do, the rest of the slides, it is just the application of the distributive property. That's all that I wanted to share with you. The reason why I am rushing, I keep kick out without saying goodbye. Okay, thank you so much, guys.
Bye.
Bye bye.
Bye, ma'am.
Sure.